Number 2. Write the stock system names for the following compounds. So stock system. We're going to run into a couple of times where what the compound we're looking at should not be named using the stock system. Normally we'd use the prefix system. That's all well and good. Just realize that this question is in fact asking us to use the stock system. So when we look at something like magnesium perchlorate, okay, the normal name for magnesium perchlorate is it's just a magnesium perchlorate. There's no Roman numerals. So this would be the normal way of naming magnesium perchlorate, because magnesium is only ever going to form a +2 charge, right? It's not a mystery because this is in main group 2. Main group 2 cations always form +2 charges. So normally we would not have a Roman numeral in here, and we read it just like we have here, and we'd expect the reader to know that magnesium has a +2 charge, perchlorate has a -1 charge, and then they would have to figure out that we would need 2 perchlorates in order to balance that out ionically. But in this problem, we want to show stock system names. We want to use the Roman numeral. So here we have iron, and then this is nitrate, so it's some sort of iron nitrate. What's the charge on the iron? Well, we know the charge on the nitrate. Look at your polyatomic ion sheet, you'll see that it's -1. There are 2 of the nitrates, so that there are a total of 2 negative charges, right? -2 overall. So that -2 has to be balanced out by this single iron atom, so this must be iron 2 nitrate. C, we have a nitrite. Okay, we have a nitrite, NO2. There are 3 of them. Looking at the polyatomic ion sheet, we see that nitrite also has a charge of -1. We see that there are 3 nitrates, so 3 -1 charges, so that's a total of -3. Again, that -3 needs to be balanced out by whatever this single iron is. This iron must be iron 3. So iron 3 nitrite. Looking at D, we have CO, which is cobalt, and then an oxide here. So it's some type of cobalt oxide. I see there's only 1 oxygen, right? So that's a total of -2 charge, right? -2 charge. That needs to be balanced out by this single cobalt. So this cobalt must be a +2. So this would be cobalt 2 oxide. E, looking at dinitrogen pentoxide, right? So this is N2O5, right? This is what we're supposed to figure out from the name, N2-O5 from the pent, right? So if oxygen is always having a charge of -2, we're going to give oxidation number of -2 to oxygen. There are 5 of them, so that's a total of 10 minus charges. 10 minus. So there must be 10 plus to balance that out. That's going to be supplied by the nitrogen. There are 2 nitrogens, so together 2 nitrogens are supplying 10 pluses, 10 positives. Right? So that means each individual nitrogen is providing 5. So we have nitrogen 5 oxide.